Welcome back, developers. So, if you've ever wrestled with extending an AI framework only to feel like you've completely lost control of your application's core business logic, well, you're definitely not alone. Today, we're diving into an explainer to demystify exactly how to configure and safely extend AI Fabric for your Spring Boot applications. We're going to focus on how raw dependencies magically transform into conditional, highly governed runtime capabilities, and we'll do all of this without sacrificing your absolute authority over the domain. Let's get right into it. Okay, first things first, let's dispel a massive myth right off the bat. Building a resilient AI architecture does not mean cramming all your routing rules into one giant, unreadable master YAML file. And it definitely doesn't mean hard-coding everything directly to a static LLM prompt. AI Fabric is built to seamlessly weave AI right into your Spring Boot apps, so it's not configured by one single master file, and you definitely shouldn't be copy-pasting the framework's orchestrator into your own codebase just to make a tiny tweak. Instead, AI Fabric is this living, layered runtime model. Here is our blueprint for today's explainer. 1. The layered runtime model. 2. Dependencies and auto-configuration. 3. Scoped precedence rules. 4. Routing providers and prompts. And finally, 5. Safe application extension points.
Let's kick things off with Section 1, the layered runtime model. So, the shape of your runtime doesn't just spontaneously generate out of thin air. It actually emerges from 5 distinct cooperating layers. You can think of it like a funnel of authority, where each layer answers a totally different question about what your application is allowed to do. First up, we have Maven dependencies, which just make implementations available on your machine. Second, Spring Boot auto-configuration conditions step in to decide which of those available beans actually activate. Third, typed AI.properties configure your external behaviors and credentials. Moving up the funnel to step 4, entity YAML and annotations define what your specific application records contribute to the AI context. And finally, right at the very top, your application beans supply the actual business policy and any domain side effects. It is a beautifully structured hierarchy of control.
Moving right along to Section 2, Dependencies and Auto-Configuration. Now, there's a massive contrast you need to wrap your head around here, the difference between mere availability and actual activation. Adding a Maven artifact just puts compiled code on the class path, right? It literally just makes an implementation available to the JVM. But it's the Spring Boot conditions, things like missing beans, enabled configuration properties, or specific required classes that actually turn the feature on and build your effective bean graph. Remember, auto-configuration acts as a conditional gate. It is not just a blanket component switch. It's specifically there to protect your application context from unnecessary bloat.
So, how does this actually play out in practice? Well, don't just assume every framework bean activates just because you dropped a module onto your class path. If a feature is unexpectedly absent, always check 3 things: the artifact, the property switch, and the required prerequisite beans. For example, did you know that the AI.enabled master switch defaults to true, but capabilities like semantic search actively require vector and search services running just to activate? Also, keep in mind that the add-enable AI infrastructure annotation is just an optional marker for discoverability. It doesn't manually import the framework. Normal Spring Boot auto-configuration still handles all the heavy lifting. And crucially, if you provide a custom bean, like say a custom chat session storage provider, the default JPA implementation will automatically back off. You are quite literally always in the driver's seat.
All right, let's look at Section 3, Scoped Precedence Rules.
You know, it's super tempting to assume there's this universal YAML always beats Java rule in modern frameworks. Spoiler alert, there isn't. In AI Fabric, each subsystem has its very own explicit resolution order that you really need to learn. Let's walk through how these conflicts get resolved. For Spring properties, normal Spring Boot precedence applies, but curated packs are explicitly loaded last, meaning they sit right at the bottom with the lowest precedence. For searchable content, the system prefers @AI searchable fields right in your code first, and then it falls back to YAML definitions. What about annotation metadata? Interestingly, existing YAML definitions actually win there, and annotations just append the missing pieces. Any completely missing configs are just disabled. And for your indexing strategy, the framework checks @AI process method level annotations, then @AI capable operation annotations, then the entity default, before finally falling back to asynchronous processing. So as you can tell, it's precise and it's highly scoped. And this right here is exactly why you shouldn't mix concerns across these configuration planes. Honestly, it's a recipe for disaster.
Keep your code local facts tightly bound in annotations, but let the entity YAML remain the deliberate, authoritative catalog of your application's policy. Mixing these, like putting tenant access rules directly inside an LLM prompt or sneaking browser flags into a provider registration, creates incredibly brittle, unmaintainable designs. Think about it. Your prompts should influence tone and wording. They absolutely shouldn't be authorizing a tenant or bypassing critical security checks.
Which brings us to Section 4, routing providers and prompts.
It is absolutely vital to separate two specific phases in your mind: provider registration versus provider selection. Look, you literally cannot select an LLM, an embedding, or a vector provider until its implementation has been correctly registered as a Spring Bean first. For example, modules like the Spring AI module conditionally add adapters to the Bean graph. Only after that registration actually happens can you use configuration properties to explicitly select it, like setting ai.providers.llm provider as your active choice. So registration provides the capability, while selection dictates the active path. They're two entirely independent choices.
Now, AI Fabric deliberately separates model purposes into two distinct camps: orchestration and generation. Orchestration is strictly for extracting structured intents and planning operations. Generation, on the flip side, is for producing user-facing answers and summaries. So why does this matter to you? Well, this separation means you can configure entirely different models, temperatures, and fallback behaviors depending on the specific job. You might want a highly analytical and maybe more expensive model for planning a complex back-end task, but a much faster, cheaper model when you're simply summarizing a chat for the end user. It's all about using the right tool for the job.
When it comes to resolving prompts, AI Fabric operates by removing duplicates and keeping the first occurrence it finds, based on a very strict precedence. This actually gives you a massive advantage, because it means you can surgically override specific templates. Let's say you just need to change one single confirmation message. You just drop a custom ClassPath version into your project and boom, that takes top priority. If a template isn't there, it checks the curated pack, which are basically reviewed domain defaults for things like commerce or support. And finally, it falls back to the base version, which is your complete fallback bundle. So you never ever have to rewrite an entire prompt family just to tweak one tiny edge case.
A quick note: if you're using curated packs, treat them as a reviewed starting configuration, not some invisible runtime personality. Why? Because their property source is always loaded last. They always have the lowest precedence. Your deployed application configuration will always override their defaults, and this is a really powerful architectural decision. It allows you to effortlessly narrow an allow list, swap out a provider, or lower a retrieval budget right in your own properties without ever having to fork or edit the curated pack artifact itself.
Finally, let's wrap up with Section 5, Safe Application Extension Points.
The golden rule here is simple. Always choose the narrowest extension point possible that owns the missing behavior. Look closely at exactly what your developer need is. If you need a completely new LLM or embedding infrastructure integration, simple. Just use a Spring Bean that implements AI provider or embedding provider. Do you need to intercept a cross-cutting stage in the orchestration? Create an ordered pipeline step. Building out custom chat persistence? Just swap in a chat session storage provider. For your core domain read and write logic, stick to an annotated @AI action bean. And a quick word of warning. If you're bringing in action catalogs via a validated AI action registry contributor, duplicated action names will fail registration entirely. The framework intentionally protects you by throwing a hard error, rather than quietly overriding your actions and causing some nightmare runtime mystery.
You now have the power to turn raw dependencies into conditional, highly governed runtime capabilities. The framework gives you these robust contracts, but you always retain ownership of your domain logic. So take a hard look at your architecture today and ask yourself a critical question. What can you safely remove? Because a clear architecture names both the modules it absolutely needs and the modules it strictly does not. Thank you so much for joining me on this explainer of the AI Fabric configuration and extension model. Keep building and keep those application boundaries strong.